Alright, so we're working with rates of change, and let's see what this problem has for us. So sand falls from an overhead bin and accumulates in a conical pile with a radius that is always 4 times the height of the pile. If the sand falls at a rate of 160 cubic feet per minute, how fast is the height changing, which h equals 10? Okay, so I'm just going to write down all the information that was given here. I'll write it down over here. So let's see. The sand falls at a rate of 160 cubic feet. Well, I know that cubic feet is a volume measurement, and I also know that this is a cone. That's what conical means. So I'm just going to write down the volume of a cone. So V equals 1/3 pi r cubed, nope, sorry, not cubed, pi r squared times h. Alright, so maybe I'll need this, maybe I won't. Always good to have it. I also know that the radius is always 4 times the height of this conical, so that's 4h. And I also know that the rate of change, so the rate of change of the volume is 160 cubic meters per minute, or sorry, feet per minute. So I know that the change in the volume as time changes is 160 feet cubed per minute. Another way of writing dv over dt is you can write it as v prime of t. So how the volume is changing with respect to time, and we also know the time at which it's happening when h is 10 feet high. Alright, and what we want to know is how fast the height is changing. So how fast is the height changing? So what we want to know, our question is, what is dh over dt? Right, so how is our height changing with respect to time, or how fast? Okay, so let's get started on this guy. So the first thing is that I know that I'm going to want to take the derivative of this volume function. It would be nice if instead of having r and an h in here, if I just had one or the other. Well, notice that r equals 4h. So what I can do is that I can take this 4r and I can plug it in, or I'm sorry, my 4h, and I can plug it in for my r over here. So let's start writing over here. Volume equals 1/3 pi, and now instead of putting r there, I'm going to put 4h squared times h. And what that's going to give me is that my volume is going to be, so let's see, 4 squared is going to give me 16. I'll just move that out here in front with the other constants. Don't forget pi is just a constant. Then that's going to be h squared times h. That's going to give me h to the third. Great. Now, if I want to figure out what dh over dt is, what I need to do is I need to take the derivative of this guy. Well, since this is an equation, I have to take the derivative of both sides in order to keep it balanced. So this is going to be, well, the derivative of v is dv over dt equals, and that's going to be 16 over 3 pi times, and then the derivative of 3h, well that's, or h cubed is going to be 3h squared. Now don't forget, if we're doing the chain rule in this guy, the derivative of h is going to be dh, and we're taking the derivative with respect to time, so over dt. Well, what was h? Or I'm sorry, not h. What was v prime of t? Well, that was 160. So we are going to replace this guy. That is 160 feet cubed over meters equals, so that's 3, so that's just going to be 16 pi times, well, what's h? Well, I know I want to figure this out when h is 10, so we can take this 10 and plug it in for h. So that's going to be 10 feet squared dH over dt. Great. So now, if well, let's go a little bit higher than that. So now, I'm just going to clean this up just a little bit. I'm going to take this 10 feet and I'm going to square it. So I'm going to have 160 feet cubed per minute equals, so that's going to be 1600 pi feet squared times dH over dt. Well, I want to get rid of this, so I'm going to divide both sides by that 1600 pi feet squared. Divide this by 1600 pi feet squared. Now when I do that, notice that these units are going to cancel out. I'm just going to get left with feet on the top. So if you plug this into your calculator, what you're going to get is 0.0318. And remember the units, this is feet per minute. And that is how my height is changing with respect to my change in time. So this would be your